Hello Internet, welcome back to our Voxel Terrain. So this project has been going on for a while. We're returning to it because we need to still figure some things out. So what I wanted to work on today is actually texturing this thing. So our Voxel Terrain can be textured, and it's based off of these colors. The issue is it's just literally taking three textures and blending them based on the colors. I don't want to do that. I want to do a little bit more, go a little bit beyond that and add some more stuff to it. So I figured we kind of pick this up and kind of lay the groundwork for some more complicated stuff in the future. I have some ideas on how we can get sort of like the Worms cartoony shaded style, but we're not going to be doing that here. We're mostly going to be focusing on how to actually get things to blend a little bit more realistically instead of just fading between one another. So what we have right now is a really basic triangle with a green side, a blue side, and a red side. Those are the three colors that we're going to be using. So these are the separate channels for our textures. So this is going to support three unique textures. Theoretically, we could add a fourth using the opacity, the alpha channel, but we're not doing that for now. It's not needed. If you've ever used a graphics rendering textbook or anything, hopefully this looks familiar to you. This is like the default graphics rendering thing. It kind of demonstrates how things blend and everything like that. We're not going to get into what makes this work. How all this blending actually happens behind the scenes. That's all barycentric coordinates that we're not going to really touch. But anyway, this is where we're going to be starting with. So I just have a really basic voxel shader here, which just renders those colors. So I've got the color here that's getting passed in, and then a bunch of other stuff. And then finally, we just render it. So all I'm doing is just multiplying our texture by our input color to get that color. So since our texture is white and we don't have a color set, this whole thing just becomes white, passes into this, and this sets it. So that's sort of how we're getting there. What I want to do is actually have three of these main textures. So we're going to have our texture 1. Yeah. Sure, we'll have texture 1 and 2 and 3. And I'm just going to do all of this right now. And then the other thing I want is each of these is going to have a height associated with it. So texture 1 height is also going to exist. And eventually we'll add things like normal maps and stuff that will get blended in as well. But what we need to do the blending that I'm thinking of is just a height map. So effectively what we're doing is we are going to be taking the scale, this scale, not that scale, the scale from our color, which represents the strength of whatever texture it is at that point. And then we're going to also be using the input or the height to determine what is there. So if we have like a giant rock in our texture, that will actually protrude more into the other one, into the other texture than, or into the other terrain than some of the other ones. So that's sort of what I'm trying to get here. Whether it works or not, I don't honestly know, but that's sort of what I kind of want to play with. A lot of texturing things do that. So anyway, rambling all over the place. So let's create a bunch of samplers here, just so we can actually read these things like that. And then I need 3 more for the heights. Ooh, that's not right. There we go. So we'll plug in the heights like so. And so this is going to get all of our data out of these into here. And so now that I have that, we're actually going to need the UVs. So UV texture 1. And this is just going to grab the UV for this texture. We're going to share UVs for all of these, just so I don't use up all of my input variables. because you do have a limited number. I think it's like 8. It actually depends on the shader level you're using. But anyway, there's a limited number and it will just burn through them really quick. So the first thing I want to do is actually take this input color. Yeah, so let's just take this input color and say if the input color dot red dot r is greater than the input color dot b or the input color dot g. And I'm just going to stick this in a max function. So we take the maximum of the other two and see if either one of those is greater than r. And if not, then we're going to grab the first texture and just draw that. And so this will be like the first step. If anybody knows how to get rid of this if, I was trying to think of some sort of function to do it, but I don't know of one. Branching stuff like ifs is pretty slow in shaders. They're not really designed for that. So if you can get rid of them, things go a lot faster. Anyway, I'm gonna copy this 2 more times and hopefully actually spell things right. Oh, geez. Doing everything wrong. Else. This can actually just be an else statement, because if the other two aren't correct, then this one has to be. So we should be able to use that. Else if the input.g, rg, so let's plug this in. So this is going to be our red, texture 1. This is going to be our green, and then this will be our blue. So we'll just comment that there. And then I'm just going to move up our albedo texture here. Our UV got renamed to texture 1, I think. It's not a great name, is it? Oh well. So we're going to take our color, write it there. I'm actually going to get rid of this color because that's just going to get in the way. And then let's copy and paste this 3 times. And then we just need to use texture 1, texture 2, and then texture 3. Now I don't know what we're going to get out of this, but theoretically, this should get us hard lines between each of them. If I didn't forget things, that would be nice. We're missing a parenthesis there. So this gets us just white, because all of our textures are just white right now. So what I need to do is actually assign some things here. Yeah, so that's kind of cool. So I can grab kind of a weird color though. Let's see here. Grab like grass, and finally we'll grab something else. So we're getting 3 different colors, and that's what we want. We want each texture to be sort of its own independent thing, and we want them to have a hard line that's going to be defined by the normal. So these second textures down here are what are actually going to influence this and actually cause this to not be just a straight line along this triangle here. And so that's where some of the complexity comes in. So I'm kind of curious, why aren't we getting... Oh, I know what's happening. So this is my triangle rendering code. It's super simple. I've skipped a bit. So we need to actually set the UVs. So let me just do that quickly. Vector 2. And let's set this to new vector 3, or vector 2 actually, of 0, 0. That'll be the top, I guess. Yeah, bottom actually, bottom left. And then the other one will be in the top, so 0, 1. And then the final one is going to be on the bottom right, so 0 or 1 0, sorry. And so that should get us UVs because we didn't have UV textures. So I just need to get this to regenerate, which doesn't do automatically. So I'm just gonna reattach our triangle renderer here. That goes wonky. Interesting. Why? Oh, I removed the mesh filter. Oops. That's not gonna work. There we go. Huzzah. So now we have textured stuff and our textures actually show up. That's a step forward. So what I need now is to rename all of these so these actually make sense because they're all named the same thing. And then we need to actually get a depth out of each of these. So we're probably going to be using the red value from each of those textures to actually set the depth. And then we can just do some basic subtraction in order to test this. So we can just subtract, we'll actually add the height, I think. I think that makes the most sense. So what do we want? Good question. Texture 3s. There we go. Let's just tack on height, and we're only going to sample red. Like that. There we go. So all of those should work now. By default, if you don't specify one, I'm going to have it be black instead. So there's nothing, there's no height to it. So it's low down. So if you try to overlap something with a texture, it will take over more. That just makes more sense to me. So we're going to create 3 heights, height 1, height 2, and height 3. I guess that's what we're going to call them. And so this is just going to be the same thing. It's going to just do a texture 1 height and take the input UV of texture 1. Yeah, so we have to take that and then we'll just grab the R from there. So that'll just be the red channel from each of these textures. And then we can just change that. Oops. So that each of them line up. And the name should be good. And then all I need to do is actually add to this input color. So instead of using the input color directly there, I'm actually going to just modify it here. So we're going to have a fixed 3. Let's do a float 3 of the color just so it matches what I'm using above. And so that is going to be equal to float 3 of our input color.r plus, we're going to want to move this down a bit so it's below these heights because we're going to actually want to use them in this calculation. We're going to add height 1 to this. Input color. I think we may want to do some multiplication. I've never actually done something like this before, and I haven't really done any reading either. I'm just kind of trying to reverse engineer it. So I don't actually know how this effect is done. I know it's common, and I know it's used a lot of places, but I don't know if I need like multiplication or anything like that. But I think we should be good. And if not, we can tweak it. So there's our input colors. We just dropped all of the inputs and just used the color variable we created. And so, theoretically, if I drop something on here, it should start taking things over. Let's actually grab, I have some textures here. Let's use these. So for texture 1, we'll use that with your height map. For this one, we have our frozen ice, that'll be 2. And we'll give that height. And then we have the concrete down here. Ooh, that's not right. And we drop that there. And now these kind of blend. These may not be the best textures for this, admittedly. but you kind of get this idea where like the sand is kind of coming over the grass, but it's not on the grass. I wish I had a good example. Like if I have like bricks, for example, where the bricks have an indent, this effect should be fairly obvious. You know what? I think I'm not sure I like this. Like, okay, so it works, and I get that it works, and it looks all right. But I think we can improve this. So what I'm thinking, I'm going to regret this so much. We are going to drop all of that. Actually, before I do that, let me save a copy. That's a good idea, because I may want to go back. Cool. All right, so we have a copy. So, okay, that's kind of weird. Sure. We have our voxel shader. What I want to do now is actually pull this stuff out. So this is going to be a little bit funky. We're going to have an output albedo. So if you don't know, albedo is actually a astronomy term. Astronomy, astrology, astronomy. Astronomy. Definitely astronomy, not astrology. We're not talking about star signs here. So albedo just represents the emission from a black body, which is like our sun, for example. So albedo, we'll just set that equal to float 3 of 0, 0, 0, just so it compiles for now. And then this is going to be our text 3. I'm going to use bad names again. I don't know why I say I'm going to use bad names. If I know they're bad, why don't I just fix them? But we can do that after I actually have this working, because I'm skeptical. So what we're doing here is grabbing each of these colors, and then what I'm going to do, I'm going to need to figure out this function. So there's a function, it's called a sigmoid. I don't know if it's going to work in this case, but we are going to try. So what a sigmoid is it's used a lot in like machine learning, but it's a function around the 0 axis that goes like this. So it looks kind of like the opposite of a tan wave. It's the opposite of a tangent, which looks kind of like a Harry Potter lightning bolt or whatever. But this is that, but along the x-axis. And so what that means is that it goes from -1 to 1, but it will never go above 1, which means, theoretically, if I'm thinking about this right, if we modify that scale a little bit, we kind of shrink it down so it kind of grows faster, the initial bit is going to be almost negligible, and that will happen for really small values. But as it gets greater and greater, it will get more and more prominent. And I think that's going to work. I don't actually know, but we're going to try. And the worst that happens is it doesn't work. So what we're going to do is just multiply this by that sigmoid, which is going to be 1 divided by 1 times e. I'm just going to approximate that as 2. That was a very questioning 2. Yeah, we'll do 2 times x, which is just going to be our color, times some scale, which I will set shortly. Actually, because I have no idea how this is going to work, I'm going to plug that in as a variable to our shader. So definitely just making this up on the spot. No idea how this is going to turn out. But I think it's worth trying, which probably means it's going to go horribly wrong. But oh well. So I've created 3 of these functions. Each of them are keyed, so their x coordinate is going to be based off of that color, the strength of that color. So theoretically, this albedo should be equal to the sum of these plus text 3. And that should solve that. So all we need now is this scale. So I can just drop that there. I tend to use the same, between float, fixed, and half, I tend to use the same one as similar things that are already there. There are differences between them, but to my knowledge on modern graphics cards, I don't think there's much of a difference. So I tend not to pay that much attention to it. But I think it is still a thing on mobile devices. I might be misspeaking there. I'm not familiar enough with it, but there are differences between those. Anyway, this should get us a broken thing. Unexpected identifiers. Oh, geez. Those are all random errors. We don't need to worry about those. Let's try adding semicolons and see if that works. Kind of looking Fallout. I'm getting a Fallout vibe out of this. So that didn't work. And part of the reason this function isn't correct yet, like I said, it goes from -1 to 1. So negative values are obviously going to be negative, and positive values are, this is never going to get close enough to being positive to what we need. So what I'm going to do is add 0.5 to each of these and multiply this result by 2, which means I think I can just add 2 here. I don't think I can do that because that will, for negative values, that will still be wrong. So I want to shift this function up by 1 actually. So then it will be between 0 and 2. And then divide it by 2. Yeah. And that will get it between 0 and 1. So we now have a function that is between 0 and 1, with 0.5 being somewhere in the middle there. So this should get brighter. Well, it's brighter. Ooh, that's really bright. I think there's a better function for this. I should probably look it up. Nah. All right. Let's see. So I think, well, that's going to be, let's divide this by 3. I don't think that's right. Yeah, still dim. That's just a wrong assumption on my part. Just because we're summing these 3, they've already been divided because our vector, our color, is a unit vector. One thing I do, I'm not convinced this is going to work at all. But I feel, well, hold on. But that should, I don't know. I don't know what, well actually, hold on, I have an idea. Let's take this out, float t1, let's go full on bad test variable names, t2 and t3. So I'm just going to save these here. And then what I'm going to do is sum them. And so float of t sum is going to be equal to t1 plus t2 plus t3, which means this is the total scale, I guess, of whatever we have. And so what I want to do is actually scale these down. So if this becomes, say, 2, that means the total power of whatever we're displaying is two times as strong as we intended. So we need to scale everything down. But if everything is kind of in the middle, then we have to scale things back. Again, I'm making this up on the spot. So, so let's divide it by that sum for each of these and see what happens. Kind of curious. Well, I may have done that. No, that should be right. Oh, ha. That's why it's wrong. Because we're not scaling our textures at all. So text1 times equal t1, and let's do that 3 times. Cool. And then that should now have a scale of 1. Yeah, but it's still overpowering. Like, that grass is just way strong. So unless I guess that looks all right. It's like negative 19-ish. Yeah, positive values don't turn out, but negative values actually, that seems to look all right. And you'll notice, I don't know if you can tell in the video, but these are a lot smoother than what we were getting previously, which is good. It means things are actually kind of smooth. They do blend quite a bit. Like, there's still bumps here from our glacier, I guess that is, which might be a little bit strong. But we can kind of tweak that. The scale kind of scale kind of breaks things if you go too far, but it works. I imagine what's happening there is we're getting like division by 0 errors. But anyway, yeah, this is sort of what I wanted to get done here. Well, previously was what I wanted to get done. This was just sort of an addendum of my own interest. So what this does is it allows us to kind of blend these textures. And so theoretically, as long as we have a depth map, a depth texture, height map, whatever you want to call it, as long as you have that, you can actually plug that in and these will kind of blur together, which makes it useful because now you don't get these hard edges and you don't get just like that classic, like, I don't know, early 2000s just texture gradient, which just doesn't look good. So I think this looks all right. If you guys have ideas for how we could improve this, I'd love to hear them, or if you have other ideas for how we could maybe texture this. Our voxel terrain should be able to be textured by anything that uses the vertex color. So if you have ideas, let me know. Or if you have other ideas for other videos, I'm always looking for things to try out or experiment with. So if you've got ideas, throw them my way. If you have any ideas on how I could improve, I'd also really like to hear that, because I'm constantly trying to, make this channel better. And it's really hard for me to figure out what needs to change because I'm just me. And when you make something, it becomes harder to kind of critique it. So if you guys have ideas on how I can improve, I really appreciate that. So that's it for now. Until next video, see you, Internet.